Hi guys, thank you for coming back for another problem. So let's go ahead and do this. In the earlier video, we had solved a quadratic inequality by using test intervals, and today we're going to solve another one, okay? Using the same technique, okay? So let's do this. So to recap, how do we solve a quadratic inequality by using test intervals? Step 1 and 2, pretty much, let's go ahead and combine them. So that way I can just say 3 steps, okay? How do we solve a quadratic inequality by using step intervals? Step 1, find the zeros. Step 2, find the test intervals. Step 3, do what you gotta do to find the answer. Okay, so yeah, that was my spin. Okay, so remember, we are not given the liberty to solve this degree 2 inequality or quadratic inequality however we like. We have to use test intervals to answer, and we are asked to write our answer in interval notation. So let's do this. So the first step is to find the zeros. If you want to find the zeros, then you have to do the equivalent of setting it equal to 0. So let's go ahead, add 3x to both sides. Okay, long story short, short story long, fix it so there's a 0 on one side and everything else on the other. When we add 3x to both sides, that will give us 2x squared plus 3x minus 2 is greater than or equal to 0. Okay, so I want to know what makes it a 0. Let's go ahead, factor if possible, and then we'll swap in the equal sign at the end. So prerequisite step when it comes to factoring is to watch out for common factors. But unfortunately, these terms don't have any factors in common other than 1. So now we got a trinomial, and you know my deal. When we have a trinomial, I'm always crossing my fingers and hope that the leading coefficient is 1. But in this case, it's not. Okay, so because the leading coefficient is not 1, we are going to factor however we like. We have been factoring using the AC method. Depending on what semester you catch me in, you may hear me say a different technique. But for now, we're going to use the AC method to factor. Okay, how do we use the AC method? So remember, the gist of the AC method is to split the middle term so you can have 4 terms and then factor by grouping. So let's go ahead and do the corresponding X game. Corresponding X game is that we want factors of A, C that add up to B. And you know I love to label my A, B, C. We want factors of A, C that add up to B. Product of A and C, namely 2 and negative 2 is negative 4. A value of B is 3. Remember, you can switch the sides. It's okay. So factors of negative 4 that add up to 3, and then there's a 4 and a 1. And in this case, the larger factor has to be positive. So let me go ahead and check. Product is negative 4. Sum is 3. You're good. Again, take like 2 seconds. Oh, sorry. Take like 5 seconds to check your answer. So let's go ahead, split the middle term. When we do, the variable part of the middle term is x. So when we split it, we will replace that 3x with 4x and negative 1x. So let's do this. So we factor however we like. Together we will be using factoring by using the AC method. So the first term stays put. It's the middle term that gets split, and we are replacing it with positive 4x and negative 1x. You can put the 1 or you can omit it. It's a personal choice. Minus 2 is greater than or equal to 0. And if you need a refresher on how to factor, then go back to look for that playlist, something about factoring. Alright, now that we have 4 terms, let's go ahead, follow procedure, factor by grouping. We group the first 2, we group the last 2, and then take it from there. GCF from the first group, 2x squared and 4x have a common factor of 2x. So let's go ahead and do this. When we factor it out, first term over common factor will give us x. Second term over common factor will leave us with 2. So one group down, one more group to go. So now let's go ahead and ask ourselves, what's the GCF of the second group? As you can see, x and 2 do not have any factors in common other than 1. So if 1 is the greatest common factor, so be it. But in this case, we're going to factor out a negative 1. Why? Because we want to make sure that we start on a positive note. Who cares if the rest of the terms are negative? When we factor out a negative 1, negative x over common factor will leave us with x. Negative 2 over common factor will leave us with 2. And again, it is no surprise that the binomial factors match. If they didn't, then our x game is wrong. Okay, so let's go ahead, factor out that GCF of x plus 2. When we factor out the x plus 2 from the expression, first product over common factor, the binomials cancel out, and that will leave us with 2x. second product over GCF, the binomials cancel out, and that will leave us with -1. Okay, let's go ahead and bring down the rest of the problem. So remember, how do we solve quadratic inequalities? By using step intervals. Step number 1, find the zeros. Okay, so again, if you want to know what makes it a 0, you have to set the inequality equal to 0. So we have it right there. Let me go ahead and speak to myself, write zeros, and then we have that the product, we're gonna replace the inequality symbol with the equal sign. Okay, so find the zero. So I want to know what makes the quadratic a 0. Okay, so product equals 0. If a product equals 0, then one of these factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, after we subtract 2 from both sides, that will give us x equals -2. If the second factor equals 0, after we add 1 to both sides, that will lead to 2x equals 1. And when we divide both sides by 2, that will give us x equals 1/2. So I'm trying to show off for you guys by doing stuff in my head, but if I was taking the test, I'm not gonna lie, I would show each and every step, because when I do stuff in my head, it's not that I can't do it, but you'd be surprised how many times I forget my own name. So I show my work because I want to avoid making careless mistakes. Alright, so let's go ahead and identify those zeros. So the zeros are going to be -2 and +1/2. So let's do this. And this is an important piece of the puzzle because we need these zeros to split the number line into test intervals. I'm not a crossroads. Yeah, I'm at a crossroads of where to continue writing. I don't want to, but I'm gonna go ahead and start a new column. So let's go ahead and use these zeros to split the number line into test intervals. So let me go ahead and zoom out. So here's a line. As soon as we highlight a number on it, it's a number line. -2 is smaller, so we should see it first, and then 1/2 is larger, so we should see it thereafter. If you want to put the decimal, that's fine. Okay, now I want to know, are these endpoints part of the solution? Are these zeros part of the solution? Well, to make that call, you have to look at the inequality symbol. If the inequality symbol has the equal to part, then those zeros are part of the solution. So let me go ahead and put a little love note. Closed. Can you see it? Yeah. Use a closed circle. Okay, so let's go ahead and graph them. So we found 2 solutions. Okay, 2 solutions so far is -2 and 1/2. Okay, so how do we solve a quadratic inequality? By using test intervals. Step number 1, find the zeros. Step number 2, use the 0 to split the number line into test intervals. If we have 2 zeros, then guess what? We're gonna have 3 test intervals. Okay, and as I said in the earlier example, again, go back to the other video, I need you to label them, number them. Test interval number 1, 2, and 3, and then I need to see where each interval is tested. Okay, so let me go ahead and zoom in now. Okay, so test interval number 1, we're gonna test out any value of our liking as long as it's less than -2. With your permission, we're gonna test out -3. Okay, again, someone said, what if I want to test out -39? You know what, go for it. I mean, it's already tough enough as is. Now, where should we test it? You know, which inequality should we use? Should we use the original one? Should we use one of the revised ones? And honestly, it doesn't matter. The book will always say use the original one, but you know what, to me, it's like whichever one looks easier for me to use, that's the one that I will use. For me, it's a little bit easier to compare to 0 versus -3x. So with your permission, we're gonna test it into this one. Let me go ahead and highlight it for myself. Alright, so the inequality reads x plus 2 times 2x minus 1 is greater than or equal to 0. So let's go ahead and see if our test value really is a 0. So we have our test value of -3 of whatever your heart desired plus 2. When we multiply it by 2 times our test value of -3 minus 1, I need to know, is this really greater than or equal to 0? Take your time, punch it in if you have to. do what you gotta do. Sum of -3 and 2 will give us -1. Product of 2 and -3 is -6. Difference of -6 and 1 will give us -7. And the question of the hour is 7 greater than or equal to 0? Last time I checked, 7 is bigger than 0. So in this case, because our test value is a solution, that means that every other real number in that interval is going to be a solution. So let's just go ahead, graph it. So again, do we have to graph the answer? No, nowhere does it say you have to graph it. But again, the worst thing you can do to yourself is actually do the algebra, but then never answer the question. Okay, I've seen it before. Okay, so let's do this. So one interval down, 2 more to go. Test interval number 2. We're going to test out the interval from -2 to 1/2. You can test out whatever you like. If we go with integers, I guess it's -1, 0, or 1. You could pick a decimal for all I care. Let's go ahead, test out 0. So I want to know, is 0 a solution? I'm not going to write down this inequality again. As long as you read it once, that will make it so much easier to follow. Okay, so let's do this. So we have our test value of 0, or whatever you picked, plus 2 is greater than, times 2 times our test value of 0 minus 1 is greater than or equal to 0. Sum of 0 and 2 is 2. Product of 2 and 0 is 0, and that will leave us with -1. Product of 2 and -1 is -2, and the question that I'm going to ask myself is this: is -2 bigger than 0? This is like a lie. Okay, -2 is not greater than 0, so it doesn't check out. You can put false. Okay, now I want to highlight that 0 is not a solution. Since 0 is not a solution, that means that no other number in this interval is going to be a solution. So let's cross it out for dramatic effect. Okay, so 2 intervals tested, 1 more to go. Test interval number 3. So we want to test out any number that's bigger than 1/2. I'll stick with 1. If you want to pick like 99, go for it. You do what you got to do. Okay, so we cannot read each other's minds. This is why it's very important for you to organize your work. Okay, identify the zeros. Where am I? Identify the zeros. Use the zeros to split the number line into test intervals. Please label like 1, 2, and 3. When you test each interval, tell me which interval you're testing. Ideally, it will be nice if you go in order, but things happen. Okay, label which interval you're testing, tell me what value you're testing, and show me the outcome. All right, so let's go back to what we need. Okay, so you want to know, is 1 a solution? Let's go ahead, plug it into this one. So we have, where am I, x, which is 1, plus 2 times 2 times x minus 1. And I need to know, is that greater than or equal to 0? So let's simplify. Sum of 1 and 2, where am I, is 3. Product of 2 and 1 is 2. Difference of 2 and 1 is 1. And product of 3 and 1 is 3. So the question of the hour is 3 bigger than 0? And the answer is yes. So check it out. Since 1 is a solution, that means that every other real number in that interval is also going to be a solution. Okay, so that's it. There's no more intervals to test out. Let's just go ahead, claim our full credit. So what is the solution set? I'm going to say it in English. So the solution set is given by all the numbers that are at most, that are less than -2, and all the numbers that are at least 1/2, so the numbers that are bigger than 1/2. So let's go ahead and press our neighbors. Okay, in interval notation, let me go ahead, zoom out. Okay, so in interval notation, it's going to be the interval from -infinity to -2, where -2 is included, so bracket. Because we have another interval, we're going to use the union symbol because we're way too cool to write the word or. Okay, interval from 1/2 to infinity. Remember, the infinities are always out or parentheses, and 1/2 is included. Okay, so that is my answer, and I'm sticking to it. Okay, so I cannot highlight enough. As you can see, there's like a lot of board work going on. I cannot highlight enough the organization. So I need to see the zeros. I need to see where you split the number line into test intervals. Test intervals need to be numbered, 1, 2, 3. Each test interval needs to be tested. So you tell me the interval number, you tell me the test value, show me your outcome, and then do what you gotta do. Okay guys, that's my time. Thanks.